There are problems with using regression for forecasting. If we look at this particular data and compare the data points to the regression line, we can see here at the lower end, all four of these data points are above the regression line. Same thing at the upper end. They're all above the regression line. In the middle, however, they're all below the regression line. This is a pattern. We can see there's some pattern in the data that our model's not fitting. In fact, the data was created using two lines. First, a line with a lower value of slope, and then a line with an upper value of slope, and then some random variables were added together to give us the data point. So what we have with this data is really data with a trend, and the trend changes on us. With regression, and the problem with regression is this data point, and this data point, and this data point all have the same impact on the regression line. What we want to do is have a way of forecasting where we can put more emphasis on newer data so that the model can adapt to changes in our data and changes in our pattern. Holt's model is that model which will have an adaptive characteristic. It's going to weight newer data more than older data, so it will adjust to a shift in the data like we have here. We'll see that. The formulas to apply Holt's model may look confusing or challenging, but it's just a simple extension of the exponential smoothing model. The forecast, the first part of this forecast, is the exponential smoothing model, and all that's added to that is a trend component. We have a trend in our data. We expect sales to increase every week or every month, depending on how we're measuring sales. So we expect a linear increase, and that's just this trend component. If we look at the updating formulas, this first formula is exactly the same formula in exponential smoothing for updating the level based on our newly observed actual data and compared to our forecast that we had. What's added is a formula to update the trend. So there's really just two additions to Holt's model from the exponential smoothing model. It's really the addition of a trend component and a formula to update that trend component as we get new data. So to initialize the model, we'll use regression. We're going to use the first four data points to initialize the model. We take those data points, get the x squared values, the xy values, the sums and the averages. We need to use regression. And we'll get a slope of 9.9. Means we see in those four data points an average increase of 9.9 per week. And our intercept is at 20.5. With this data, we can initialize the Holt's model. Here we're looking at the same four data points that we're using to initialize the model. And under the level here, we're using the regression formula, just like we did in the previous video about regression forecasting. We took the intercept plus one period of slope to give us a value of 30.4 compared to actual sales of 32. Here we added 2 periods of slope to get us 40.3 versus 38, and so on. This fourth value is one of the two values we're going to use for Holt's model going forward. It's the level. It's what we think sales are underlying the data that we've seen, the average typical value. When we look at forecasting data, we're trying to fit a model that'll get an approximate value or give an underlying pattern. We know that there's going to be variability due to factors we don't understand. When we're forecasting, there's all kinds of circumstances which cause the data to vary. If we were omniscient beings, we would know all those things and we could exactly tell what demand's going to be. But because we're not, we say there's an underlying level, there's an underlying model, and there's randomness around that model. So our basic level, we think the average sales level in week 4 was 60.1, pretty close to what we observed. There was some variability. We also think at this point that sales are increasing by 9.9 units per week. And at this point, with the model initialized, we would take a forecast using Holt's model. We're going to get the forecast in period t plus 1 will equal the level in period t plus the trend that we think we have in period t. And that's what we would have here. We have a level of 60.1 and one period of trend gives us a forecast of 70. With Holt's model, we can expand this formula. We know that if we go one more period in the future to week 6, we think the trend's going to add 9.9 to it, so our forecast is 79.9. Every period we move forward, every week we move forward, we add 9.9 to it. We would continue on until we get new data. Once we find out what sales are in week 5, we're going to update Holt's model forecast with that new data. We're going to make a slight adjustment, and then we would have a new series of forecasts going forward with that revised data. Suppose we find out in week 5 that sales were 52 and we had forecast 70. Two things we know about forecasts. First, forecasts are always wrong. And second, there's not a company that thinks their forecasts are great. Everybody's unhappy with forecasts because we're trying to predict the future. And we're never going to be right and nobody's going to be happy. But we have to have a plan before we can deviate from it. We look at the forecast of 70. Sales were 52. We over forecast the value. So what Holt's model says is that we need to adjust the level and need to adjust the trend a little bit. We're not going to say that the level is 52, but we're going to move towards that with these formulas. We need to come up with a new value for the level that reflects the fact that we over forecast and reduce that level a little bit from what we thought it was. We thought it was going to be 70. Also, we're going to adjust the trend down because we over forecast. We're going to take a slight reduction in both of these values based on that one data point. And if we repeatedly over forecast, as we'll see, we're going to adjust the model further and further until we do not deviate so much from the actual data. To update the level, the formula is L sub t is equal to alpha times the actual value in period t plus 1 minus alpha times the forecast value we had in period t. That's how we're going to fill out this new level value. We're talking about t being 5, so the level in period 5 is going to be alpha times the actual value in period 5 plus 1 minus alpha times the forecast value in period 5. When we substitute in for alpha, we're going to use here alpha equals 0.3. Again, in exam situations, you'll be given the value for alpha. As a forecaster in practice, you're going to choose a value for alpha and for beta that adjusts the model to do as good a job as possible fitting the data. Here we're going to use alpha as given 0.3. That's a little bit high for an alpha value. Again, 0.2 is fairly typical. The actual sales that we had in week 5 and period 5 is 52. And we're going to take 1 minus alpha, or 0.7, times the forecast we had for period 5, which is 70. We're taking 30% of this new value and 70% of what we thought we had. So we're moving towards that 52, but not fully. And when we calculate this out, we're going to get this equal to 64.6. So our new value for the level is 64.6. We over forecast a fair amount. Instead of 70, now we've moved down to 64.6. When you're doing calculations like Holt's model, if you understand the underlying logic, you should be able to check your work. You should know that for the new level, it has to be between what you forecast and what the actual sales were. And because alpha is 0.3, we're only going to be 30% of the way towards the 52. We're going to move down from 70 towards 52, and the value we get is 64.6. Next, we have to update the trend. The formula we use is the trend in period t is equal to beta, another parameter that decides how quickly we adjust the trend, similar to how alpha decides how quickly we adjust the level. We use this beta times the level in period t minus the level in period t minus 1, and we're going to add to that 1 minus beta times the trend we had in period t minus 1. This difference between the level in period t and a level in period t minus 1 represents an observed trend. What do we see the level change? In our case, between week 4 and week 5, how much did it change by compared to what we thought the change should be? If we talk about t for period 5, this is where we want to find our new trend value. Then we're going to take beta times the level in period 5 minus the level in period t minus 1 or 4, and 1 minus beta times the trend that we had in period 4. Substituting for beta, we have 0.4, which again is quite an aggressive parameter. In practice, he'd probably be more like 0.2. And we're going to have the level in period 5, we just calculated now, as 64.6, minus the level we thought we had in period 4, which was 60.1. This difference is 4.3. So we've observed a change of 4.3 between what we thought the level was in week 4 and what we think the level is in week 5. And we're going to take 40% of that and add it to 60% of what we thought the trend was before. The trend in period 4 was 9.9. So we over forecast. We've dropped the level down from the 70 we thought it would be to 64.6. And when we do the math, we're going to drop the trend down to 7.7. Now, with new parameters, we can forecast sales in period 6 and beyond. Again, the formula for the Holts model forecast is that the forecast in period t plus 1 is equal to the level in period t plus the trend in period t. We now want the forecast for period 6, so that means we take the level in period 5, which we just calculated a new value for, plus the trend in period 5, which is equal to 64.6 plus 7.7, which now gives us a forecast of 72.3. Remember before, we had a slope of 9.9, so we thought we would have 79.9 here, but now we've revised our Holts model, and that's going to be our new forecast value. Going forward from this point, with the information we now have, knowing the sales value in period 5 was much less than what we forecast, we're going to adjust our forecasts in the future, starting from a lower level and having a lower value of the trend. When we find out that sales in week 6 were 63 compared to 72.3 for what we forecast, we again need to make some adjustments. Using the Holts model formulas, the level in period 6 would be alpha times the actual value in period 6 plus 1 minus alpha times the forecast value in period 6, which is equal to 0.3 times 63 plus 0.7 times 72.3. Again, we're going to take 30% of what we just saw, but the bulk of the value for the level is what we thought it should have been, 72.3. We're going to adjust the level from 72.3 to 69.5. To update the trend, we're going to use the formula T in period 6 is going to be equal to beta times the level in period 6 minus the level in period 5 plus 1 minus beta times the trend in period 5. Substituting in, beta is 0.4. The level in period 6 we now estimated as 69.5, minus the level in period 5 was 64.6. This difference is 4.9. We're going to take 0.6, 1 minus beta is 0.6, times what we thought the trend was, which was 7.7. So we thought the trend was 7.7 previously. Since we overforecast, it looked like 4.9. So we're going to make an adjustment and have a new trend value of 6.6. Given these new values for the level and trend, our new forecast for week 7 is going to be equal to the level in week 6 plus the trend in week 6. In other words, what we thought the level and trend were after adjusting for the new sales figure of 63, which is under what we forecast. We over forecast again. So we're going to take 69.5 and add the 6.6 trend to it and have a new forecast of 76.1. Again, with these new values of trend and the level, we'll make new forecasts going forward, and the process continues. When we get a new value for sales, we'll update the level and trend and redo the forecasts that follow. If we continue this process on, we used 4 data values, 4 weeks worth of sales figures, to initialize the model to get this level and this trend, and we used regression to do that. We have a number of data values where we can actually compare our forecast to these sales values, the ex post forecast region. Notice that our trend started at 9, it dropped down all the way to 2.7, and then picked back up again to 24. Finally, the last weeks, 16, 17, 18, 19, we have our actual forecasts of the future. If we look at this graphically, what we see is that we initialized our forecast and we were forecasting where we were over forecasting the values, we were adjusting the trend down, then the data changed on us, and so we were under forecasting, but we adjusted, and our forecast in the future looks like a pretty good representation. Certainly much better than the straight line linear regression result that we got before. Here's a typical exam problem. Given a value for alpha and beta, and we're given a method of initializing the model that's different than the example we just did. The reason is, for an exam, we don't want the complexity of doing a regression model and Holts model. So the simple initialization method says, for the level in period 2, use the actual value that you have for sales in period 2. For the trend in period 2, use the difference between the actual sales in week 2, period 2, and week 1 or period 1. So what we're going to do is say we're just using 2 data values to initialize the model. Our level is just going to be this 39. We're going to look at the change between week 1 and week 2, which is a change of 12, and that's going to be our trend. This method is simple and it's useful for making a simpler exam question, but in practice it's really not a good idea for initializing a model. Suppose we had some data that looked like this. We clearly have a trend through our data. We would expect a forecast to look something like this. If we use the method of initializing the model that we just described previously, our trend would actually be negative, and it would take a while for the model to adjust to this data. Whereas if we take 4 periods worth of data like we did before, our initialization will give us a trend that matches the trend in the data. Using just 2 points is not enough to really get a good representation of the trend. To solve this Holts model problem, we'll use a spreadsheet. We have the data from the problem, and we've also created cells to contain the alpha and beta value. Again, as a forecaster, you're going to pick those values. So it's useful to have them in the spreadsheet as a variable value, as a cell that you can reference and change so you can see how it impacts the forecast. We need a couple more headings. We're going to need a column for the level in any period. We're going to need a column for the trend in each period. And finally, a column for our forecast. We'll take those cells, we'll align them, we'll make them bold, we'll underline them, and while we're at it, we'll align the cells underneath. First thing we need to do is to initialize the model. And according to the problem, we're going to take the level in week 2, in period 2, being the same as the sales value. So that's L2 is equal to A2 for initialization. Our trend, we're going to say it's the difference in sales between week 2 and week 1. we would expect in 1 week to have 1 week of trend. So that makes sense in terms of a method to initialize. Again, as previously explained, it's not the best method to use. It's not a difficult thing to use regression to initialize the Holts model. But here we're going to use this simple method. So we'll highlight these first 2 rows of cells to say that's what's used to initialize the model. Our very first forecast then is just taking the level in week 2 plus the trend in week 2 to give us a forecast of 51. So from initialization, we think the level in week 2 is 39. We think sales are increasing by 12 each week. So that gives us a forecast of 51. We look at what sales actually were. Again, we pretend that we don't know the future as we're making the forecast. We made a forecast of 51. At the end of week 3, we found out sales were 54. So in this case, we slightly under forecast. So we expect the level to be something above 51 because we under forecast. We expect the trend to be a little bit above 12 once we apply the updating models from Holt's model. So first, to update the level, we're going to take alpha. So we're going to select cell alpha. And again, for Windows computer, we'll use the F4. For a Mac, we'll use the Command T to make that an absolute reference because we want to copy this formula down, always referring to cell C1 as the alpha value. So it's going to be the alpha times the actual sales. And we're going to add to that 1 minus alpha, again an absolute reference, times our forecast. Oops, didn't quite get there. Times our forecast. Gives us 51.6. So we look at that number. Our forecast was 51. We slightly under forecast. So Holt's model says increase the level to 51.6. That makes good sense. Next, we're going to get the formula for updating the trend. We're going to take beta as an absolute reference times, we'll put some parentheses in here, the level that we just calculated minus the level we thought we had before. So this represents our observed trend in the level from week 2 to week 3. And we're going to add to that 1 minus beta, again an absolute reference, times the trend we thought we had prior, which was 12. This gives us 12.18, so it's increased slightly. That makes good sense. We can now take these formulas, and this is the beauty of spreadsheets, and just drag them down to week 5. We want the forecast for week 6, so we drag that down 1 more cell. We see that there's a lot of decimal places being displayed, so let's take these cells and we'll display them with 1 decimal place. So here we have our forecast using Holt's model for week 6 as 86.9.